In this video, we're going to talk a little bit about machining, the machining process for manufacturing. We've linked to a few videos that will give you a few more details and go a little bit more in depth and show you some actual examples of machining in practice. But I wanted to spend just a minute or two going over the most important aspects, what I feel are the most important for a designer to understand. There are two kinds of machining. One is called milling and the other is called a lathe. Sometimes a lathe is referred to as turning parts, so you might hear that nomenclature as well. In a milling machine, your cutting bit, which looks a little bit like a drill bit, but your cutting bit is more or less stationary. It's spinning really fast, but it's not moving up and down or left to right or anything like that. And your part is actually what moves. Whereas in a lathe, your part is what's being moved, or your part is stationary, and your cutting bit is actually moving in and out left to right. So those are kind of the main two differences between a mill and a lathe. Milled parts are typically kind of blocky in shape. You know, they're your brackets, your blocks, things like that. Whereas turned parts or lathed parts are cylindrical in nature. So if you're trying to decide, you know, which process to use, think about the shape. If it's a cylindrical kind of concentric part, then a lathe is the route that you want to go. If it's a more blocky shape, then it's a mill is the route that you want to go. Machining is a great process for low to moderate quantities of parts. So, you know, anything from one piece up to a few hundred parts. That's a kind of a generally typical quantity for machined parts. It is that way because there's no upfront tooling that you have to invest in, not any real expensive tooling that you have to invest in order to start machining a part, like there would be for injection molding, right? If you're injection molding something, you have this really expensive tool to pay for before you can even start making parts. But when you're machining something, you just get a block of material, aluminum, or maybe it's nylon or steel or whatever it is, and you mount it into your mill or your lathe, and then you start cutting. And maybe there's some programming that goes on, but there's no very costly tooling up front that you have to purchase. So it's great for these low quantities because there isn't that, you know, barrier to entry, so to speak, economically. Why it's not great for really high volumes, although sometimes it is used for high volumes, but generally it's not considered a high volume manufacturing process because there are some economies of scale, but not to the degree like you would have with injection molding or die casting, where you can pop parts out very quickly once you have your tool. Injection molding or die casting, you might have a new part created every 30 seconds or every minute and a half or something like that. Whereas with machining, even when you have CNC machining going and your program is running, it might take you, it depends on the part, but maybe it takes you, you know, 20 minutes or 45 minutes or an hour and a half. It really depends on the complexity of the part, but you're not getting parts every, you know, 30 seconds or 1 minute. And so for that reason, it's not a great process for really high volumes when you get into production. But for low to moderate quantities, it's a great route to go.
I do have a question. And in the first bullet point that you mentioned, you said there were two different types of machining. And could you mention them again? What are the two?
The two different types of machining are milling and a lathe. The machine is called a lathe, and the process is often referred to as turning.
Okay, so between the two, if I am a designer in SolidWorks, does it matter how I should make my design in SolidWorks based on how the machine type that I will be using, or no?
Yeah, absolutely. And it really depends what you want your part to look like, what the functional requirements that drive the part geometry are. Again, if it's kind of like a blocky shape, then you're probably going to be using a mill. And if it's a cylindrical shape, you know, like a rod or a bar or a shaft, and maybe there are some features in there, but those features are all concentric with the axis of the part, then you're going to be looking at a lathe to make those parts.
And when I'm on SolidWorks designing the parts, are there certain principles that I should follow based on the type of machining that we use ultimately, or no?
Yeah, there are definitely some design guides, some rules to follow for machining, whether it's a lathe or a mill, and we'll get into that a little bit later in the course.
Okay, got it.
Okay, so that I think that's all the kind of the high level items that. Oh, one more thing actually. Both machining processes using a mill or a lathe, you can achieve very high tolerances. In other words, you can manufacture parts that are very accurate, down to a few thousandths of an inch. Generally, a turned part is going to be a machinist will have an easier time achieving a very high tolerance on a turned part than they will on a mill. Tolerances for turned parts, 1 or 2 thousandths of an inch is not difficult for a machinist to achieve on a lathe, but on a mill it's more like maybe 3 or 4 or 5 thousandths of an inch to is kind of that easy range to hit. You can get better than that. You can even get down into 10 thousandths of an inch tolerances. But that becomes more difficult and more costly. So if you're trying to design something economically and you don't need, insanely tight tolerances, then 1 or 2 thousandths of an inch for a lathe is pretty easy to hit, and say 4 or 5 thousandths of an inch plus or minus for a mill is also something that's relatively easy to hit for a good machine shop.
So one of the bullet points here says CNC machining allows a designer to create a more complex shapes, while manual machining is limited to more basic shapes. Could you talk a little bit more about what defines a shape being complex?
Sure, yeah. Think about if you have a block of material, and that block of material is moving in just one direction, and you have a cutting bit that is removing material.
If you could put your hands higher. There you go, yeah.
So if you have a block of material that's moving across your mill, for example, and you have a cutting bit that's removing material as that block moves across, if you're on a manual mill, you are manually controlling the linear motion of that block of material. And so you're limited in the geometry that you can create. It's pretty easy to create straight features on a manual machine, whether it's a mill or a lathe. But when you start getting into curved features or complex curvature, curves that exist in multiple axes, that is pretty much impossible to do on a manual machine, because there's no way that the human mind and hands can turn the wheels in just the right time and in just the right sequence and do that over and over in a repeatable manner to produce that kind of complex curvature in a part. Whereas with CNC, it's all programmed into the machine, and so the machine is very precise and very repeatable and knows exactly what that tool path needs to be to produce that more complex shape.
I think it's pretty important for the students to know exactly what CNC stands for. It does.
CNC stands for Computer Numerical Controlled, and it's an acronym that's used, and it just means that the machining tool path, so the trajectory that tool makes, or the trajectory that the part makes within the mill or the lathe, that's all programmed using software into the machine, as opposed to just being manually moved by a person's hand cranking that wheel back and forth.
And tell us about how long, or the complexity involved in creating the CNC, because you have to program it. Does that take a long time, or how does that work?
It does take some time, and typically a programmer for a CNC machine is well paid, and so you're paying for a professional's time to program this CNC machine, and the machine itself is also very expensive, more expensive than a manual machine. So it can take a little bit longer to get set up to make something on a CNC. So if you're just making, it really is up to the shop. I mean, I wouldn't dictate to a shop, make this part on CNC or make this part on a manual machine. I would leave that decision up to the shop. But If you're doing just a few parts, it might make more sense to use a manual machine because you don't have to do the programming, and it's a less expensive machine to use in general. But if you're making a lot of parts, then you program something into the CNC, and then you don't really even have to have anyone babysitting that machine. You just push a button and let it go, and you have someone come in to take the finished part out and put a new block of material in to make the next part. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.